Hello everyone. Today let us discuss about refraction at convex spherical surface. Refraction at convex spherical surface. We all know about refraction. Whenever light rays go from one medium to the other medium, they bend and travel. And we know the fundamentals, that is Snell's law, that is sin I divided by sin R is equal to mu, that is the refractive index of the material of the medium. Now we have to study whenever light rays travel from one medium to another medium, what happens to them. Let us study in detail. So this is the figure. This is a refraction taking place at this particular surface APB. Now this is a spherical surface. The ray is coming from rarer medium which has a refractive index mu1 to a denser medium where refractive index is mu2. Okay, let us start our study. So this is the figure which I have taken here. APB is the refractive surface and O is the object on the principal axis. O is the point object on the principal axis. Object lies in a rarer medium mu1. Now the rays from object, one ray goes from O to N, another ray goes from O to P. At N, the ray is refracted and bent towards the normal, and it travels like this and comes to I. Wherever it touches this spherical surface, we have drawn a normal. Normal means the perpendicular line. This is the perpendicular line. NC is the perpendicular line, where C is the center of curvature, and the ray travels after bending along NI. The ray which passes straight like this and comes to the pole, and it travels straight undeviated and it goes towards I. This ray, the one which is bent and the ray which is travel straight, they both meet at I and they make the image at I. So this is the introduction. Now let's go and see these details again. In this figure, APB is the convex refracting surface which separates a rarer medium and the denser medium. Rarer medium has a refractive index mu1 and denser medium has a refractive index mu2. Let P be the pole, and C be the center of curvature, and R is equal to PC, that is the radius of curvature of this surface. Suppose a point object is placed at O. It is placed at O on the principal axis in the rarer medium. Starting from the point object O, a ray ON is incident at an angle I. Here I have shown angle of incidence I. And after that, after refraction, it bends and travels towards the normal. Normal is NC. Normal passes through center of curvature. Now the refracted ray is Ni. It bends towards the normal and it makes a refractive angle R. Here I have shown the refractive angle R. Now you can go and see here clearly. Here is the refractive angle R. Okay. Then after that, another ray OP, as I told you earlier, it is incident normally at pole, and after that on the convex surface it is incident normally and passes undeviated like this. They both meet at I. So the one which comes refracted, that is Ni, the one which is undeviated, that is passing through Pi, they both meet at I. Therefore the image is formed at I. You can see in this bigger picture, image is formed at I here. And then after that, so I is the image of this object O. Now we have to see and derive the expression, the relationship between all of them. Let us draw NM perpendicular to the principal axis. This is the principal axis which I am showing here. So the principal axis is this one. Okay. So now if you take the principal axis, to the principal axis we have drawn a normal NP. Sorry, NM is the normal. I'll go back to the big picture. So here you can see NM is the normal, that is the perpendicular line which is drawn onto the principal axis. And then after that, let us take some this one angles. Here is alpha, here is beta, and here is gamma. I'll go back and show you in the bigger picture. This is alpha, this is beta, and this is gamma. And after that, let us see triangle NOC. Let us take triangle. You can see clearly. Go back to this one, NOC. So this is the triangle NOC. That is the triangle. Here I is the exterior angle. Alpha and gamma are the interior angles. Therefore, exterior angle is equal to sum of the opposite interior angles. I is equal to alpha plus gamma. I is equal to alpha plus gamma. That is what I have written here as equation number 1. That is what I have written here as equation number 1. Similarly, let us go back to the picture and see again. That is triangle NIC. Let's go back and see the triangle NIC. NIC. This is the triangle. So in this triangle NIC, this is the triangle. Here gamma becomes the exterior angle. Then the opposite interior angles are R and beta. R and beta. So gamma is equal to R plus beta. So let's go back to that place. Yes, here. So gamma is equal to R plus beta. This is what I have taken. Therefore, R is equal to gamma minus beta. Equation number 2. As I have taken it as equation number 2. Then after that, let us suppose all the rays are paraxial. So paraxial rays means the rays which are parallel to the principal axis, and they make a small angle with respect to the principal axis. Then the angles, all these angles I, R, alpha, beta, gamma, all are very small. You all know one thing, no? When theta is small, sin theta is equal to, when theta is small, we all know sin theta is equal to theta, and tan theta also is equal to theta. So this is what from the trigonometry. When theta is small, sin theta is equal to theta and tan theta is equal to theta. Therefore, alpha is equal to tan alpha, beta is equal to tan beta, gamma is equal to tan gamma. Then tan alpha from these triangles, if you see NM by OM, so this is alpha. You can see here, or if it is small here, I'll take you back to the big picture. Tan alpha, you can see here, alpha is equal to opposite side NM divided by OM. Okay, so let's go back to that place, and then you can see here tan alpha is equal to NM by OM. So that's over. And the next is beta, tan beta, this one, this triangle if you take, tan beta is equal to NM divided by MI. NM divided by MI. Tan beta is equal to NM by MI. NM divided by MI. So that is about tan beta. Then after the tan gamma, gamma is here. Here you can see in this triangle tan gamma, that is equal to opposite side NM by adjacent side MC. You can see there. So let us write 3 of them. NM by alpha, tan alpha is equal to NM by OM, tan beta is equal to NM by MI, and tan gamma is equal to gamma, which is NM by MC. But if you see in this figure, P and M are close to each other. I'll take you to the big picture here. P and M are very close to each other. So instead of M, you can also consider P because P and M are very close to each other. M and P are very close to each other. So OM you can write as OP. Hope you're following. So OM is equal to OP. Similarly, MI is equal to PI. MI is equal to PI because M and P are close to each other. Alpha is equal to tan alpha is equal to Nm by Om, that is equal to Nm by Op. Similarly, tan beta is equal to beta, which is Nm by Mi, that is equal to Nm by Pi. Gamma is equal to tan gamma, which is Nm by Mc, that is equal to Nm by Pc. Why? Because P is close to M. So when P is close to M, we can take like that. Okay, so let us continue. Let us say all these angles are paraxial, so they are very, very small. Then we know the Snell's law for refraction. This is the Snell's law. Mu1 sin I is equal to mu2 sin R. Here also angles I and R are very small. So when the angles are small, we say the same thing. Theta is equal to sin theta. When theta is small, sin theta is equal to theta. Similarly, when I is small, sin I is equal to I. When R is small, sin R is equal to R. So, substitute these two values, I and R, in this equation 4. In this equation 4, you will get now, what you will get? Sin I, mu1 sin I is equal to mu2 sin R. So, mu1 in place of sin I, we will substitute I. In place of sin R, we will substitute R. So, we will get mu1 I is equal to mu2 R. This is equation number 5. So, for all these things, I have put equation 3. So, earlier I have shown you equation 1 and 2 previously. So, this is 1, this is 2. Already I told you. Now, this one all together we have taken as 3. All of them together as 3 we have taken. This is Snell's law is equation number 4, and then replacing sin I with I and sin R with R, we are getting the fifth equation, that is mu1 sin I, that is I, is equal to mu2 sin R, that is R. Let it be equation number 5. So we got up to this point, and then let's continue. Then mu1 I is equal to mu2 R. This is what we got. Then substituting equations 1 and 2 in 5. So let's go back and see what are equations 1 and 2. So this is equation 1, this is equation 2. I is equal to alpha plus gamma, that is equation 1. And R is equal to gamma minus beta, that is equation number 2. I is equal to alpha plus gamma, equation 1. R is equal to gamma minus beta, that is equation number 2. So let us substitute these two equations in equation 5. This is equation 5. I means alpha plus gamma. R means gamma minus beta. Substituted. But gamma value from the previous one, that is, if you go back here, gamma is equal to Nm by Pc. Okay, so let's come back. Nm by Pc in place of gamma, Nm by Pc. Alpha is equal to, from the previous one, alpha is equal to Nm by Op. Okay, Nm by Op. Then after that, beta, from previous one, beta is equal to Nm by Pi. So let us substitute Nm by Pi here. That also we have substituted. Then in all these things, if you see Nm is common in the numerator, you can cancel Nm from the 4 terms because it is in 4 terms common. So after cancelling Nm, we get mu1 into 1 by Op plus 1 by Pc is equal to mu 2 1 by Pc minus 1 by Pi, because Nm is removed from 4 of them. Then mu 1 by OP, mu 1 with mu 1 we are multiplying, mu 1 by OP plus mu 1 by Pc is equal to mu 2 by Pc minus mu 2 by Pi. So now mu 1 by OP, then mu 2 by Pi, this term I will take to the left side. Here it is minus, when it comes to left side it becomes plus. Mu 1 by OP plus mu 2 by Pi is equal to mu 2 by Pc minus mu 1 by Pc. So I will write here, so mu 1 by OP plus mu 1 by Pc is equal to mu 2 is equal to mu 2 by Pc minus mu 2 by Pi. So now if you see in two terms, Pc is common in these two terms. So we will rearrange the terms, that is mu 1 by OP. This I will bring to this side, which becomes plus mu 2 by Pi is equal to mu 2 by Pc. Then I will bring this to left side, it becomes minus, then it becomes minus mu 1 by Pc. Then mu 1 by OP plus mu 2 by Pi is equal to mu 2 minus mu 1 by Pc. So this is what we got here. And after rearranging, mu 2 minus mu 1 by Pc, that is equation number 7, which I have taken as equation number 7. Then applying new Cartesian sign conventions, OP is equal to U, but it is opposite to the direction of the incident ray. Incident ray is from our left to right, but we are measuring from the pole towards the left. Therefore, U is equal to, according to Cartesian sign convention, OP is equal to minus U. Pi, which is in the direction of the incident light, we take from left to right, that is Pi is equal to V. Then Pc is equal to radius of curvature, that is equal to plus R. That also we are measuring from left to right. Okay. So let us continue. Using all these things, OP is equal to minus U, Pi is equal to V, Pc is equal to R, substituting in equation number 7. So equation number 7 means this is the equation number 7. Mu 1 by OP plus mu 2 by Pi is equal to mu 2 minus mu 1 by Pc. So let us substitute all these values here. Mu 1 by this one minus u, mu 2 by V, mu 2 minus V, mu 1 by capital R. So rearranging, first we will write this term because it is positive. Then you will get mu 2 by V minus mu 1 by U, that is mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. So this is called the equation relating the terms U, V, R, refractive indices mu 2, mu 1. So generally this is also asked in the examination. Derive the expression that is relating the terms object distance U, image distance V, radius of curvature R, refractive indices mu 1 and mu 2. So when they ask like that, we have to derive this. So this derivation is very, very important for the exam. Not only for this, they will also use it for the lens maker's formula, which I will discuss in the next video. So after that, this is the main equation which we are using now. So this is the main equation which we are using, this one, that is equal to mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. If the first medium is air, let us say the first medium is air. First medium is air means mu 1 is equal to 1. Second medium is equal to anything, let it be mu 2 is equal to mu. Then substitute in this above equation, you will get mu by V minus mu1 is 1 by U is equal to mu minus 1 by R. So this is the formula which we have to use. Okay, very important one. This will be used for deriving the expression of lens maker's formula. And also we have to do lot of numericals based on this formula. So learn carefully. Bye. God bless you all. See you in the next video. Okay. Until then, bye. Thank you for watching this video. God bless you.